Show you how to solve LEETCODE question 797, all paths from source to target, and it's a median LEETCODE question. So given a directed graph of n nodes labeled from 0 to n minus 1. So basically, for example, like this one, starting from 0 and n minus 1. Find all possible paths from node 0 to node n minus 1 and return them in any order. So in this example, the n minus 1 node is basically node 3, and you can see the input here is node 0's next node is 1 and 2, and node 1's next node is 3, node 2's next node is 3, and then node 3's next node is itself. So basically, that's how they define the graph here. And basically, they want you to write a function and return all the path to 3, and in this case that we can see is like 0 1 3, and the next possibility is that how you write the path is 0 2 3, right? So there are two paths here, as you can see, and this one they define the graph, and from the output, so basically, they want you to find all the nodes from 0 to 4. 4 is the n minus 1 node, and the answer will be the possible path is 0 4 and 0 3 4 and 0 1 3 4 and then 0 1 2 3 4 and 0 1 4, like this one here. So that's all the possible path, and n equals to the graph length here, and then 2 is bigger than 2 and smaller than 15, and basically all the constraints here, and there will be no self loops, and all elements of a graph I are unique, and it's guaranteed to be a directed graph like this. So this is a interviewed question got asked by Bloomberg, Google, and Amazon in the past 6 months. So let's look at a question like this, and if you want to write all the path that the first thing that you should realize that this is a depth search problem, and the output they want you to print all the path, then in this case you actually need to use backtracking, because backtracking is basically use the depth search to find all the path but print all the possibilities. For anything that you need to print out all the possibilities, all different combinations that you need to print out using depth search, you should think of using the backtracking. And when you use backtracking, basically you want to define that which current node that you are at and the path that you go along this line, right? And then you want to define a base case when you want to exit the backtracking, and then when you go through the backtracking, you want to go all the next node in this graph, like when you find the next node and you want to append the next node to the path, which is the output, right? And you want to run backtracking on this path, and after you run the backtracking, to basically append 1 and append 3, right? And after you run backtracking, since the 3 is already the target node that you're trying to reach, that you can totally return this as one of the result, which is 0 1 3, right? In this case. And then after that, what you wanted to do is that you want to pop from the path. So pop the 3 and then pop the 1 so that the 0 can append the next path as 2, and then you want to go a different route from here. So that's basically all the function for the backtracking. That's the idea, the thought process. So I'm going to show you how to do this in the code. So I want to define the target node. So it said that the target it's n minus 1 node, so the target node will be the graph length and a minus 1. So in this case, and it will be the target will be the 3, right, that we're trying to reach here. And then the result, I want to put the result as a list because I'm going to append all the past lists to the result in the end. And I'm going to define the path and put a path since I'm adding items to it and also try to pop on it. And what I'm going to do is that I'm going to do it from the queue. So path I'm going to define as a DQ. So because the first node is 0, so I'm going to append the 0 to the path here. And then the next step is I'm going to backtrack this, and like I mentioned that for the backtracking I'm going to define 2 parameter. One is the current node and then the path, right? So the current node, when we write a backtracking, the first thing you want to define a base case. Basically, when you determine to exit out of the backtracking is if the current node equals to the target, basically the node 3, right? If when they equal, I want to resolve, I want to append a path, I want to append a copy of the path, basically everything from the queue. And then after that, I'm going to return from this. And then, so how do we run the backtracking? So for the next node in graph, the current node, basically the current node's next node. So for example, like I'm starting from node 0, right? So the current node is 0, so next node is 1. For the next node, basically node 1 in the graph of current node, and I'm gonna append the node 1 to the node 0. So I'm gonna append it to the queue, right? And then I'm gonna run backtrack on the next node. Basically is the node 1, and then that's the path, right? And then after I run this, I want to start popping from the queue, because once I have all the path I appended, I want to be able to pop the 3, pop the 1, so that I can go back up and then pop it. That's it actually for the DFS search function. So I'm gonna write the call the backtrack. So the backtrack, the current node, I want to start from 0, and then that is the path here. And then in the end, what I'm gonna return is actually the result. So let's see. Yep. So it works. Let's submit it. Okay. So let me know if you have any questions, or if you like the video, please give it a thumbs up and subscribe to my channel, and I'll have more questions coming up for you. Thank you. Bye bye.